Right, good evening all. You are welcome to Tutorials with Fametante the Schoolboy. Today we are going to take a look at mathematics. We conclude with the derivation of the laws of logarithm. There are two laws remaining, right? How many? Two are remaining, right? Please help me call out those laws, please. Call out those laws. Law number what? Law number what? Law number what? 3. State it for me, please. Log what?
Y raised to power z.
To base what?
Base a.
Log y to power what?
Z.
To base a is equal to what?
What is z?
Z what?
Log y base a.
Log y base what?
A.
Okay, the next one, last one is to what?
Is log a to base a equals to 1.
Number what is that?
4.
Log what?
Log a to base a equals to 1.
Log a
to base a.
is a capital letter?
No, small, not small.
Log a to base what?
A equals to 1. Number 5.
I think we have derived this. We are not there. She's calling the one that she wasn't there when we derived. She wants to pull us back there. You see the game? She missed class, so she wants to pull us back to the one we have done. Anyway, for the benefit of those that came, let's just do it. Continue.
Log 1 base a equals to 0.
Log what?
1 base a equals to
1 base a is equal to what?
0.
1 base a. What are you saying? I don't. That
I'm sorry.
is not true. Log what?
1 base a.
Log 1. No. Log what?
Log 1 to base
Is equal to what?
a. 0.
Log 1 to base a is equal to what? Okay, let's see now. Is that all? Is that all?
Log y to base b.
Log what?
Y to base b.
Log y to base c,
B
to base b,
is equal to log y to base c.
Log what?
Y to base a.
Base a over what?
Log b to base a.
Log b to base what? A. Okay, is that all?
Yes.
Okay. Sorry for those that came. We have done this topic, but we actually it remained number 3 and number 6 because we proved the laws. We derived the prove it to be sure that it is true. Before we do what? Accept it. We don't just cram things here. We prove it to be sure that it's correct. So that's what we are doing. So it remained this and this, but because of Chineye called it out, let me just do it. But it's already in their notes. But I don't know why she wasn't in the class that day. Unless she was in the class, but her mind wasn't there. Now let's go. Let's do it. Now let's start with the first one. Log y raised to power z to base a is equal to z times log y to base what? A. Now let's start from here. We have always known that y, so like that y is equal to. We have always known that y is equal to, if y is equal to b, if y is equal to a raised to power x, right? That log y to base a is equal to what? X. True of us. Do you agree with me? Do you agree with me? Good. Now, if that is the case, now what if we have What if we have, if you raise this thing now, if you raise the both side to the power z, what will it look like? If you raise both sides to power z, what will it look like? Let's see how it goes. If we raise this one now to power z, remember what you do to this side, you also do what? Do to the other side. And raise this to power z. That means y raised to power z is equal to what? A what? A what? X and what? Because this will multiply this, true of us. This. From the law of indices we have done so far, we know that if y is equal to a raised to power a, that it will be this, right? And if you raise y to power what? Z, it will be what? This. You agree with me now? Now, if that is the case let us now carry this. That means x is equal to what? This. That means x is equal to what? Log what? Y to base what? A. Remember what you are trying to prove. Now, what it means actually is that y raised to power z is equal to a raised to power what? X what? Z. Now, remember that we have a bracket here before, right? And we have this before. Now, if you look inside this bracket, what can we do to this thing to get what is inside this bracket? What can we do to this? If this is a raised to power z, that means a is actually what? Y, which we have done. Remember, we want to show that log y raised to power z over a is equal to what? Z log a raised to power log y to what? Z. Now, if you check here, let me put it so I don't confuse you. If you check here properly, what is inside this bracket is also what is equivalent to what is inside this bracket. True or false? True or false? What is inside this bracket is equal to what is what? Inside the bracket, because they have the same what? Power. True or false? Now, what else do you think we can do here? What else do you think we can do here? If we find the log of both sides, if we find the log of both sides to base A, if you find the log of both sides to base A, what do you think will happen? Check where. Someone should tell me. Chinaya, look at this properly. Look at this properly. If you find the log to both sides, base A to both sides, what do you think will happen? If you find log A to both sides, what do you think will happen? Tell us. What I asked you to do was to find, what if you find log, if you get both sides, log this to base A and log this to base A, what it will give you? That's what I asked you to do. No problem, just look up. Now, if you have y raised to power what? Z is equal to what? Remember here is what? A raised to power what? Xz. Are you aware that this is what? Index form, right? If you change this to logarithmic form, you have something like this. Log what? Log what? Good. Log y raised to power what? To base what? Those that were here when we did logarithm, is it true? Huh? Is it true? Huh? Is it true? They're keeping quiet. Is it true? Huh? What is the problem? When is it true? Now, this statement is saying what? Remember, you lifted the here something here up. A lifted something here up. What did A lift up?
X.
What? X what?
Z.
X what? Z. A lifted what? X what? Z. Remember what we say in our changing from index to this and that. If you have from the definition of logarithm, the logarithm of a number is what? Is what? The power to which the base will be raised to give that what? That number. That's the logarithm of a number. So if you have that, y is equal to a. So log y is equal to b raised to power a. So that means log y to base a is actually equal to what? No, log y to base b is actually equal to what? A. Because this a will lift this a up. You have that y is equal to what? B raised to power what? A. This is law of what? The diffusion of what? Logarithm. So logarithm of a, logarithm of y to base b is equal to what? A. Because if you raise b to the power a, you get what? Y. Listen carefully. Logarithm of y to base b is equal to what? A. Because if you raise b to power a, you get what? Y. This came from the definition of what? Logarithm. That's what we want to apply here. That's what we applied here. That if this a now raised to power what? Xz, you get what? Y raised to power what? Z. Are we together? So in that case now, that means log y raised to power z over what? And to base a is equal to what? X what? Z. But remember that we have already found the value of x as what? X is what? From here. X is what? X is what? Log y to base a, remember. Hope you remember where we got this in from. For the first thing we did, let's assume that y is equal to what? A raised to power what? X. From here we can say, okay, let's raise y to any power. We raise the power z. That means we also raise this a raised to power x to power what? Z. That's what we do. But if you raise it now, this will multiply this, and you get this. We find the log of this, and we get what? This. Remember, we are arrived at it, but we have already found x to be what? Log what? Log what? Y to base what? A. Now, if that's the case, now whenever we see x here, we put what? This thing. Okay. Anywhere we see x here, we put what? This. So if we substitute this for x, we have that log y to power z over to base a is now equal to what? We put this for x, log what? Y a times what? Times what? Z. True of us, because we are substituting this for what? X in this equation. So we have log y raised to power z to base a is now equal to what? Log y to base a times z. So if we bring z this side, we now have that log what? Y raised to power z to base a is now equal to what? Z log what? Y to base what? A. This is this what? Law. Sorry, I cut off this power. It should come from here. Now, to put it in a way that you can easily understand, let me, for those that want to copy it sequentially, but if you understood what I say, you don't need any issue, but let me do it for their sake. This is what we want to prove. We started by saying, if y is equal to what? A raised to power z. That means, if you put this in logarithmic form, that means x is equal to what? Log y to base what? A. True of us? Do you agree? Good. Now, when I say, okay, let's raise this y to power z. we have y raised to the power what? Z. Is certain as saying what? Because since y is a raised to the power x, so if you raise y to the power z, you have to raise a raised to the power x to the power what? Z. So we have a raised to the power what? X what? Z. True or false? Is it true? Okay, let me take it step by step. Is it clear now? This from the law of indices, this we multiply this. True or false? We now have that y raised to the power z is now equal to what? Ax what? Z. This is the index form. Let's put this in what? Logarithmic form. That means if this will now will come down to form the log of the base of the log. True or false? We will now have that log y raised to the power z to base a is now equal to what? X what? Z. But we already have x to be what? Base. True or false? So we bring it here and put here. We now have log what? Y raised to the power z to base what? A is now equal to what? Log what? Y to base a times what? Z. We bring the z here. We have log y raised to the power z to base a is now equal to what? Z what? Log y to base a. This is this what? Law. This rule. This law. Is it clear? Is it clear? Is it clear now? It's not clear. What is not clear about this? Tell me. Tell me where you are lost here. From where? From where? From the top. The first thing I said, remember we are talking about power. If y is equal to a raised to the power x, x is equal to log y to base a. Is it true? From law of logarithm we have done, from the logarithm we have done since, from the definition of logarithm. Is it true? Is it true? Are you sure it's true? Good. Now, remember we want to raise y to z. Now, raise y to z. What will happen here? If y is a raised to the power x, and you want to raise y again to power z, so what will you do here? Won't you raise it again? Remember y is entirely y is a raised to the power x. Y is not x, so hope you know. So that means you raise everything here to power what? Z. Our law of indices, go back to the law of indices. Look for where you have something. Check, open your book now. Where is it? Where is it? Where? You didn't write it. What I prove in this class, you didn't write it. We are not in class when we discuss it. That's the problem. If you see it now. You were in class, I proved something, you didn't write it. And you're here asking me a question you don't understand. This is the problem. Seriously, I don't know how you could take these classes. How can I be in class here trying to crack my brain to prove something? You didn't put it down. This guy said. This guy said. But I ask now, you say you are in a class. They speak out now, let us hear you. Remove that your hand from your mouth and speak out, let's hear you. Speak out, let's hear you. Huh? You know, kunime. Kakela, if you get the one. Woke kwesi de kutu kwa fuma okwa cha on gonna ga ka kokya. Iku ebu wa mani neku. That's how a man should be talking. Open and so to take will you hear me here? No, will you hear me? You go now, you do what? You start coming. You say this man doesn't talk. Now you be the first to complain. He can't even talk like a man. You complain. But here you are. You can't speak out. Okay, good. Let's assume you are not there. And when you come to a place and you were not there when you treated something, the wisdom demands that you ask those there, please, what have people done so far? You look at what they have done and copy. It's wrong. Humility matters a lot. Copy from them. Let me see what people have done. You copy it and go through it. If you don't understand something, you cannot ask questions. That's how to do. That is how to learn. You can't come to a place that people have been there since. You didn't want to find out what they have been doing since. It's wrong. There's a law of indices that says that if you have something like this, come see, you were there. Shay, or you tell us about this law. Where a power, when you have a number, we have A raised to power B or X, right? Everything raised to power what? B. What is it? Good. You multiply, use this one to multiply this one. We have what? A raised to power what? X times what? B, which is what? A raised to power what? XP. It's a law of indices. We did it in this class. That is the law we are applying here. Is it clear now? That's why it's what? A raised to power what? X times what? Z. Because everything here is raised to power what? Z. So this Z will multiply that power. Simple. And if that is on, that's why this is why Y raised to power Z is equal to what? A raised to power what? X Z. So it is this. Do you also agree with me from our definition of logarithm that if you change this into logarithmic form, it becomes what? This A will come down and form the base of this log. True of us. XZ will be here. So we have log Y raised to power Z to base what? A is equal to what? XZ. Is this one clear? Good. Is this one clear? Speak well. Is it clear? Say yes. Say yes. Go ahead. Say yes. Izu, say yes. Say yes. Say it. Let's hear you. Say yes. See, if you don't learn this in here, it will affect you. You have to learn it here. And I'm more serious too. It will affect you. By that time, you won't know what to do. Like what? Like what? So the point is that you speak out well. I don't know. I've passed through this stage. I know what I'm saying. There's a stage you reach in life. You realize that you have to learn it. It's very important. Please. You may feel bad about what I'm doing now, but with time, if you follow what I'm telling you now and start speaking out, you thank God you did. Now, this is what A raised to power what? X what? B. So this is what we did here. Now, if we now change this to what? Logarithmic form now. This will form the base, right? And SZ will now be here. So we have log Y raised to power Z to base what? A is equal to what? XZ. But we have already established that X is what? Log Y to base A. So we pull it and replace X here. That's why we got what we got here. And if you multiply where Z will come here, that is reason why log Y raised to power Z to base A is equal to what? Z times log Y raised to power to base what? A. That's this law. Is it clear now? Do like this. If you don't want to further talk, do like this. No problem. Do like this. If it's okay, so I'll take that one. Because he's becoming angry All right, so now let's go to the next one. Let's go to this one. Write it. Can I clean? All right, please write it down. Write it down so that you don't say you don't write it. But I will take it there and that time. Write it down. Let me see your notes. So where do you conclude it now? Here. If you have written that x, but x is equal to what? Log what? Okay, it's here already. You should have it so that you know that you substituted. So you don't forget when you want to go through it. Let me see your own. Rosemary, can you name me? I'll give him number. Okay. Please, fast, so that I can clean, so we can go to the next one. Do you know why I derive this? It will help you not to cram it. It will help you to understand it. You may get to a time where you may start getting confused. You look for where it came from and be able to know how to use it. And sometimes some question may come. You know, in trying to prove this now, we have reminded ourselves of about up to 3 laws of indices, 3 of us, and even other law of what? Logarithm. That's the importance of what I'm doing. I just come and write it for you like this. You just go and cram it. It's not a good thing because you may forget it. If you cram it, it will get to a point you may confuse this one with this one because you just crammed it. It's not a good thing. Try any formula you see. Please don't cram formula. Any formula you see, there's no formula that didn't come from anywhere, from somewhere. Any formula you see, try to know where the formula came from. If you want to do it in other formulas, there's no way the question will be twisted that you cannot solve the question. It's not possible. Are you done? Good. Let's go to the next one. Come and prove it for us. I will not prove it. Come. Kamsi will prove this one. Chinwendu will prove this one. Oh yeah, come. Come fast. I have done that in this class, so I will never repeat what I've done again. I'll be calling you to do what I've already done in class. Okay, Kamsi, so come and prove this number 4. After Chinwendu will prove number 5 for us. Fast. Duster. Where is it? Are you done? Explain what you did. Face like this. Explain what you did.
Log 8 base A. And A is equal to A because they are the same.
A is equal to A. Continue.
So it's now, sorry, A raised to power 1. So if you now change it to logarithmic form, it will not exist.
Okay, you have an idea about the idea, but it's not smooth. Smoothing it, clean that board and smoothing it well. You are using what here? You are just looking at this place, and I want you to smoothen it very well. Start from the index form and come down to logarithmic form. Clean everything there. Make it smooth. Hello? Try, you have the idea. What I want you to just smooth it. Smoothen it. So what did you do? Good. That's what it is. You know, any number you are seeing is actually raised power what? 1. 3 of us. So if you see 2 is actually 2 raised power what? 1. So if you see A is actually what? A raised power 1. So if A is equal to A raised power 1, you didn't align it well. If A is actually what? A raised power 1. This is the index form, right? You put this A in index form. So A is equal to what? A raised power 1 in index form. Just convert it to what? Logarithmic form. That means this A will come to base, right? 1 will remain. The power which is 1 will remain. So log A to base A is equal to what? 1. So that means that any number to its base is equal to what? 1. Simple. So it's correct. Chinwe, okay, if you are done, Chinwe, come and prove the second one for us. It's simple, it's not hard. Are you done? Good. Chinwe, come and prove the other one for us. We apply the same method as we did here, any number raised to the power of 0 is what? Any number raised to the power of 0 is what? 1. From log of what? Indices, right? So you can actually, 1 is any number, you can actually raise any number to 0, it becomes what? 1. So you can decide to use A as such number. So A raised to the power 0. Please, this should always be aligned in this form. A should be here, okay? A raised to the power 0 is equal to what? 1. So A raised to the power 0 is equal to what? 1. So if this is the what? Index form, okay? So you put it in what? Logarithmic what? Form. If you put it in what? In log. Okay. I think she's right. She's right. It's me that is not right. Here should be what? 1, and here should be what? A raised to the power what? 0. She's correct. Sorry. Here this is A. Here should be what? 1. Why here is equal to what? A raised to the power 0. So that means A will now form the base of this log 1. Okay. So we have log 1 to base A is now equal to what? 0. Simple. So the last one, this one actually, I just added it on the in this log. It's actually change of base. That's what is called change of base in what? Logarithm. Change of base. I just intentionally added it here. What it means is that if you have, listen carefully. What is this thing? Okay, let me prove it first before I tell you the implication and how to use it in calculation, okay? All right, let me prove this thing. Or let me ask, is there anybody here that can prove this one for us? Is there anyone who get money to go and prove it? If you can prove it, you drink Arusi malt this evening. Anyone that can prove it now will drink malt. You take it and go home. Who can prove it for us? So this is how to learn, this is how to study. I listed this out since, and we went to him for 1 week now, or go to 2 weeks, right? The right thing you should have done is to try it yourself. Try to see whether you can prove it. This is how to learn. This is take up challenge on your own. This is how to learn. You must learn how to take up challenge by yourself. Take up tasks on your own. Don't wait for your teacher to do it. This is in your note for going to 2 weeks now. By now, you should have done it on your own and see what you can get. That is how to learn. Okay? I hope we have timetable. I hope people have timetable used to read your books. Do you actually read, or do you just come to lesson and pack your things and do assignments if you want to do, and do the one you want to do and go? Hope you study. You have timetable used to study these things. Please, it's very important, okay? As you do your assignment, also do what? Study them. Very, very important. Now, let me prove this one. This thing is called change of what? Base. In proving this one, you will introduce a base. Now, let's assume y is equal to what? B raised to the power what? X. Let's assume y is equal to what? B raised to the power what? X. This implies that what happened? A logarithmic form, put it in logarithmic form. You have what? Log what? Log what? Y to base what? Is equal to what? X. We are moving to what? Logarithmic form. Now you can introduce you can put this to a particular base of. You can get this, put this, add a log of a base. It has a log to a particular base here. Also put log to a particular word base here. You can choose log to base A. You can choose what? Log to base A. So if you put log to base A here, you also put log to base A here. Let's see what it will give us. Because we are talking about change of what? Base. So if you put log to base A here, you have put log to base A in both sides. You have something like this. Log y to base what? A is equal to what? Log b raised to power x to what? Base what? A. Okay? Put log A in both what? Sides. So we have log A, y to base A is equal to what? Log B raised to power x to base what? A. Are you aware that this log y to base A is certain as saying x log B to base A? Do you agree with me? Do you agree with me? Do you agree with me? Good. So next thing, let's make x the subject of the what? Formula. That means we divide both sides by this, right? Yeah. So we have that log y to base A over what? I see. Over log what? B to base A is equal to what? X what? Log B to base A over what? Log, we are dividing both sides by log B to base A. We want to make S to set the formula. Why adding S again? So we have log B to base what? A. So we do what? Cancel. This will do what? Cancel. It's two of us. So we now have that x is now what? Log what? Y to base what? To base what? A over what? Log B to base what? A. So this is x. Remember that x is what here? X is what here? Log y to base what? B. That implies that, come up here, replacing x here with what? Log y to base A. We now have what? That log what? Y to base A is now equal to what? Log what? Y to base. Log y to base what? Log y to base B is equal to. Sorry, baby, sorry. Base B is log y to base what? A over what? Over what? Talk now. B to base what? A. Are they something? Are they? Yes. That is this what? We call this what? Change of what? Base. Now, look at the implication. Look at the implication. The implication is this. That if you have, let's assume you have log y to base b. What it means is that it's something with log y to any base over log b to the same what? Base. Let me fix numbers there. Let me fix numbers. Let's even test whether it's true. Okay? Let's test whether it's even true. Let's fix numbers. Let's fix numbers and see whether it's true. Let's call y4, okay? And call a. Let's call A2 and call B. Let's call B3, okay? Okay? So that means what it means is that log 4 to base what? B is what? That means log 4 to base 3 is set now saying log 4 to base what? To base what? 2 over what? Log what? 3 to base what? 2. That's what this rod is telling us. It's also certain as saying log 4 to base 10 over log 3 to base what? 10. So let's check whether this is true. Punch a calculator, let's see. Hello, Chineye, that you are Ijiabeta. Thank God, Ijiabeta. But you can come with it without using it, because there are some things you may want to prove. Remember I told you that you use it to prove something, okay? To confirm something, okay? Okay, no problem. Let's see whether we can solve it without using calculator. Let's see whether we can make something out of it. Let's see. Let's see whether we can make something out of it. Let's see if we can make something out of it. Let's see if we can make something out of it. Here is what? 3 raised to power 2, right? Yes. So if the here come here, become 2 over what? Log 3 to base 2. So 2 to base 2 divided by log 3 to base 2. We may not get something tangible from here. Or is that what we would scientific calculator? So we can then know the actual value, because this is their simplest term. You can't do anything there again apart from finding the value with your what? Calculator. Does it have log? Can we get log to any base there?
Yeah.
Let me see.
Let me
Check if you can do it. Let's confirm this to know whether it's true. After this, we now go to what is called, if you check it, we will go to what is called but you understand, but know what, how we got this in, how we derived this in, right?
Yes.
Good. Maybe tomorrow or next tomorrow, or if you go home, you can check it on your own. All these times, there are some of these calculator you can find log to any base. You can use fix any number you like, find log, calculate, drag log to that base, and divide, and so know that it will give you the same thing. It will give you the same thing. I'm sure of that one. Now, we want to, you know that this logarithm is divided into two. That's what we have not talked about, common logarithm, okay? Common logarithm. But before that, before we enter common logarithm, in common logarithm, you need a four-figure what? Four-figure what? Table. I told you to bring it. If you don't have, you go and buy it. I don't think it's expensive. Or you get any textbook, math textbook with four-figure table at the end, okay? In our next class, I think by God's grace, we'll go into that. But before then, I want to, there are some exam questions you will see. You will see logarithm that it sounds funny. From logarithm, you start solving equations, two of us. So, and also from indices, you start solving what? Equations. Those, we didn't do it when we did the indices, so I want to conclude it now. I want to conclude this part with what is called exponential equation and logarithmic what? Equation. Exponential equation and what? Logarithmic equation. Exponential equation means that from indices you start solving what? Equation. Some may be simultaneous, some may even be simple linear equations, some may be quadratic equation that you will see. So we want to look at exponential equation and what? Logarithmic what? Equation. We are done with laws of what? Logarithm, okay? We are done with what? Laws of what? Logarithm. The next subtopic we treat is what? Exponential and what? Logarithmic equation. All right, thank you. See you next time.